All right. So today we are starting with our DataCampus series on descriptive statistics. Like I said before, I stated earlier that we'll be doing a lot of preparatory classes for ahead of next year, our programs for next year. We'll do a lot of introductory statistics trainings, introductory machine learning, Python programming, and all of that. Okay, so we're going to have a very, very rich program going on every Sunday. So do well to invite your friends. Okay, now for today, we don't have a lot of people here. There are just about 4 or 5 of us in this call tonight. I know that we've not created enough awareness about this class. Even in our community, we've really not emphasized it. We didn't even really say that we are starting today, right? We didn't really advertise much of it. So let's do more. We'll do better next week. So to that end, for today, we are going to talk about something we all have an idea about, statistics. Okay, we'll start up with statistics, and then we'll dwell more on descriptive statistics. We'll just do some reminders around it. Okay, remind ourselves what statistics entails and all of that, descriptive statistics, the introductory aspects, elementary aspect of it, and then next week we go a bit deeper. Okay, we'll bring in population and sample statistics. Yeah, population and sampling aspect of this descriptive statistics. We go, a bit deeper by next week. And yeah, because we'd have created more awareness. So we're going to take this topic again next week. All right, so let's start with descriptive statistics. Before we go into descriptive statistics, let's look at what statistics in itself entails. Okay, so before I bring up the second slide, who is going to tell me what statistics? What is statistics? What is statistics? What is statistics? Who can help us? I'm going to call names. So, Adeleye, will you help? Or Adefunke? Steven, what is statistics? Let's start with
Well,
that. So who's speaking?
I can just say is the descriptive. So
Steven, right?
statistics. Yes. Just a representation of uh of a set of values. Let me just put it that way.
Okay, representation of a set of values.
Okay, excuse me,
Okay.
ma.
All right, that's interesting. Somebody else?
Yeah, it's the
Who's
collecting
speaking?
and analyzing of numeric data in a very large quantities.
Collecting and analyzing of numeric data, very large quantity. Okay.
Something like that.
Okay, somebody else. Somebody else. The truth is that every day we deal with statistics, probability, and all of that. But let's just come down to statistics first, right? Every day we do a lot of statistics, quantifying information, giving weight and values, right? To concepts, to a lot of things that we do on a daily basis. Okay, let me just give it a very brief definition, very, very brief one. To me, statistics is more of quantifying information. Okay, being able to quantify information. And what I mean by quantifying information is that you're able to attribute values, you're able to attribute weight and measures, okay, to a given set of variables. Let's say, for instance, maybe you're a tailor, and then you have 5 customers has approached you for Christmas sewing, for you to sew their clothes this Christmas. Now you have having 5 customers, that is numbers, that is statistics, right? And now you have these customers, you're able to take their measurements for each and every one of them. You have measurement. You have customer A, B, C, D, E. Their measurements are different, different heights, different body size generally. Please kindly mute yourself, please. Please mute yourself. Godwin, you're not muted. Okay. Yeah. So being able to, quantify the information that you have, being able to quantify the data that you have in any way possible, right? Being able to interpret it is statistics. So you have information about these 5 customers I talked about. You have information about their height. You have information about maybe their waist size, depending on the kind of clothes you want to sew for them. You take different measurements of body parts for these 5 customers. You've been able to bring out information or data point for for each of them. Now, being able to quantify the 5 of them, maybe you now talk about how the variability in their sizes, or the similarity in their sizes. Do you understand? You're not talking about statistics. For my 5 customers who came for sewing, okay, how do their sizes, what is the similarity in their height? Okay, then we'll not be looking at measures around their mean, the mean value of their height. Okay, how are their variations, how large are the variations in their sizes? We'll not be looking at dispersions and all of that. So these are descriptive statistics. So generally, statistics helps to understand randomness and uncertainty in our world. Okay, so that is why we are bringing in statistics, because before we bring in probability. Of course, probability has to do with randomness, has to do with uncertainty, right? In everyday scenario. Okay, so let's look at 2 types of statistics that we will be looking at here. Of course, we'll be starting with descriptive statistics, okay, and then inferential statistics will come up later. But then when we talk about descriptive statistics, what are we talking about? When we talk about descriptive statistics, what are we talking about? Let me ask that question. Remember, tonight we're just going to do these are basic things you already know, so we'll just refresh our minds on them ahead of next week. So Godwin, you came in not so long ago. Kindly share with us. When we talk about descriptive statistics, what comes to your mind?
First off, good evening, ma'am. Good evening, everyone.
Good evening,
Um, I
Godwin. Yeah.
I think it's the basic arithmetics we all know. The mean, median, and mode.
Absolutely. It has to do with the basic arithmetics, right?
Yeah, yes.
But not just that mean, median, and mode. Okay, there is not descriptive statistics. Mean, median, and mode is just one aspect or one type of descriptive statistics. So when we're talking about descriptive statistics, we are looking at the overall characteristics of our variables. Let's just say the overall characteristics of our variables, right? Now, like I mentioned, I used example of our 5 customers that came for sewing, right? And these 5 customers, I talked about how the similarity or closeness, how close to each other, how similar, right? Their sizes could be, and how different they could be. Okay, yeah. And we could also look at how over time, okay, the variation in their sizes over time. So there are different ways to look at descriptive statistics. When you want to have a holistic view of a data that you're working with, a data set, a given data set that you're working with, right? You do what we call descriptive statistics. The word descriptive is as as descriptive as it sounds. Do you understand? Yes. So when we say descriptive statistics, we are talking about description, basically. How do we describe this data, basically? Okay, we want to understand basic things about numbers, about averages, about occurrences, similarities, differences, outliers, okay, stuffs like that. So that is what descriptive statistics is all about. So it's that aspect of statistics, okay, that helps us describe our variables or help us make sense of the data or the information that we are working with. Okay, so you're able to have an overview of whatever information or data that you've gathered that you're working with. All right. So having said that, let's move a bit further. What are the different types of descriptive statistics that we have? Like he mentioned, we have the mean, median, and mode, right? The basic arithmetics, like he said. But the mean, median, and mode falls within the category of what we call the measures of central tendency. Okay, so we have measures of central tendency, we have dispersions, we have graphical representations. Okay, so in measures of central tendency, it's in measures of central tendency that we have mean, median, and mode. And what does the measures of central tendency basically do? Central tendency basically identifies the central or the average values of a data set. The values that are within the middle or the center of a given data set. Do you understand? So you have numbers. Basically, let me give an example. You have number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The middle values of 1 to 10, where you have like 5 and 6, are more like the average, kind of, right? Between 5, yes, and 5.5 and 6, within that range. Okay, so or let's just say about 5.5. So measures that identify the center of a given set of data sets, or maybe you have 1 to 10, 0 to 100%, and you're looking at average or median values. Now the middle point, you'll be looking at the 50th percentile, right? Around 50% thereabout, halfway, midway in your data. Do you understand? Now, that is measures of central tendency. We are going to explain each of them. I know we already know it, but we'll just refresh on them. Then we have what we call the measures of dispersion. The measures of dispersion describes the spread of variability of data. All right, it helps us to identify the gap. Let me use the word gap, right? How each data point is spread or is far away from the mean. So we are sorry, in measures of dispersion, we are actually calculating, okay, having discovered the mean in our measures of central tendency at dispersion level. What we are trying to do is to now um, be able to ascertain, okay, the difference between each data point from the mean, right? What data points are close to average? What data points are far away from the average? Do we have outliers? Okay. And then you may be wondering, what are outliers?
Hello, can you hear me?
Yes, yes, yes. You know.
Let me join you back since my system
Can hear
was
you.
disconnected.
Please let me know when you can see my screen again.
I'll send the screen.
Okay, thank you. Can you mute yourself, Godwin?
Can't hear you.
I don't think we can hear you, man.
How about now? Can you hear me?
Yes, yes.
Yes, yes, yes.
Yes, yes, we can hear you now.
Okay. Okay, so let's continue. Yeah, we're looking at measures of central tendency and then measures of dispersion. And we've been able to establish that for measures of central tendency, we are looking at data around the mean, the average or the center of a given data set, right? The average. Then for measures of dispersion, we are looking at the spread or variability of the data, how they are different or far away from the mean, right? Then we have the third aspect of descriptive statistics, which is the graphical representation, right? Where we have histograms, if you remember the bell curve, what we call the bell curve, the normal curve of life, the box plots, and all of that. So we are going to look at all of that. So let's start with the measures of central tendency. Let's start with measures of central tendency. Now, for measures of central tendency, we have the mean. The mean has to do with the average. And of course, it's of the summation of the numbers you have in a data set divided by the number. When you have something like this, like summation of a number, the given number that runs from 1 to I, something like that. I'm trying to remember my year 1 statistics now. That runs from, let's say, I to N, something like that. I think this is how we used to write it in statistics, right? This is N, no, don't mind it, it's looking like 7. All over the given number of occurrences or the population, something like that. So this is more like the mean, I think. Yeah, oh, I'm remembering. So mean has to do with, I think there's a formula for arithmetic mean, something like this. But let's just say that it has to do with average, right? Average. And what do we mean by average? You have a given set of data. Now I have example of about 5 customers that came in for measurement. These 5 customers have different heights. So let's just say their length, right? This is the best handwriting in the whole world. Now, let's say their length for the first person. These are not real human being length, so but let's say this person is 5 cm, the next person is 10, the next okay, let's say 5, 6. Let me not go too far. 6. The next person is 7. The next person is 8. And let's say the other person is 5. These are different numbers. The next person may be, let's say 4. Right? Let's make our customer 6. And we have another customer that is also 6 cm. So we have 6 customers, and these are their length: 5, 6, 7, 8, 4, 6. Okay. Now, if we are looking at the mean the average value, what are we going to do? Who is going to remember basic mathematics? Who is going to remember? Kindly remind us. Okay, how do we go about it? Should I promise one chicken to the person that will speak?
We will add all the numbers up and divide it by the total digit there. So it will be 5 plus 6 plus 7 plus 8 plus 4 plus 6 divided by 6.
Divided by 6. Absolutely right. So we have 5 plus 6. Press your calculator. 5 plus 6 is 11, right? 11 plus 7 is what? 18. 18 plus 8 is what?
26.
26 plus 4, 30. 30 plus 6, 36. 36 over 6 is what? 5.
6.
No, 36 over 6 is 6, so
Six.
my meal. 6. 6 times 6 is 36. Yeah, so our arithmetic mean in this instance is 6. Okay, so 6 is our mean, is the average, right? Value of the average length for our 6 customers. Now, you could wonder what is the median? What is the median in this case? What is the median? Let me remove our plus. What is the median value here? Oh, I've removed something else and joined. What is the median value? Okay, I've not explained median. 5, 6, 7. Sorry, let me pick this again. Pen. 5, 6, 7. This was 8, right? 8, 4, 6. All right. So when we are talking about median, remember we explained before that median has to do with the middle value, like the value that is in the middle. When you arrange your data sets, or the values that you have, the numbers that you have, what do you have in the middle? So we have 4. Very simple. We have 4, right? Then we have 5. Then we have 6 and another 6 and then 7 and then 8. So we have 1, 2, 3, 4, 5, 6 numbers, of course. And then how do we determine the median in this kind of scenario? If we had only 5 values, it would have just been easy to pick out the middle value, maybe the third value as our median, right? But in a scenario where we have 6 values, right? Or an even number of numbers, even number of values, what happens is that we select the 2 middle numbers, right? And then we take the average of the 2 middle values. So in this case, we have 6 plus 6 over 2. What is that? Still 6. Okay, 6 plus 6 over 2 is 12, still 6. So you see, this is a very rare scenario where our arithmetic mean and median is exactly the same. Wonderful. Okay, so but notice that these are just measures around the middle, around the mean, right? So we have the median value 6 plus 6 over 2. Then how about the mode? The mode, of course, is the number that is most occurring in a set of data that we have. Now, what is the number that occurred the most here? It's still 6, because we have 1, 1, 1, and then we have 2 of 6. Our mode is still 6. So this is a very rare case that, okay, we didn't plan this, but we have our arithmetic mean, we have our median, we have our mode, the same number. It's, of course, we know that it's not always the case. Sometimes our median could be 5, our median could be 5.5. It could be 6.5, it could be 7, okay, when you have arithmetic. Sometimes even 1 or 2, depending on the number that has the highest occurrence. So this is measures of central tendency, and we all are aware of it. We all knew it before now. Okay, so let me just erase everything. Erase everything from. All right, so the next ones that we are going to look at are measures of dispersion. Okay, like we've already explained, the measures of dispersion has to do with the spread of variability in our data sets. The spread of variability in our data set. And then we have range, we have variance, we have standard deviation. And as we all know, range is the simplest of them all, right? Now we have that set of data for our customers. What is the range? So the range, let's say, let me just pick another simple listing for this particular. All right. So let's say the range of our data we have. Oh, please ignore that. We have number 2, right? We have number 1. Let's say we have 3 again. We have 3. This 3 that is looking like what I don't know. It looks like he wants to slap somebody. Let me remove it. Okay. So random numbers, let's just pick some random numbers again. 2, 1. I mentioned 3, comma. Then let's say we pick 1 again. And let's say we pick 4. Let's say we have 5, comma. Five. And 1, 2, 3, 4, 5. Yeah, let's leave it like that. 2, 4, 6. So we have this set of data, right? Let's assume this is a data set and we want to find the range. We know the range measures the spread or dispersion of a data. Right, all right, is a measure of dispersion. But then it's calculated by the difference between the maximum and minimum. If it's in if it's in Excel formulas, right? You just take the highest value minus the lowest value. If it's in Google Sheets, you just do maximum minus minimum, something like that. So our range here is what is our range here? What is our range here? From this simple is our range. Who can tell us how we get our range? I've already said it, but identify it. What's our range?
4. 4.
Okay, how did you get 4? So we got 4
5
by
minus 1.
minus 1 from 5. Yeah, 5 minus 1. So the highest value is 5. The lowest value is 1, right? So our range is 4. Okay, so this is our range. Now, how about variance? What does variance mean? Now, for us to be able to calculate our variance, we need to first of all find our mean, right? What is the mean of this data? What is the average? The average is 2 plus 1 plus 3 plus 1 plus 1 over 6, right? So we have 2 plus 1 is 3, plus 3, 6, plus 1, 7, plus 4, 7 plus 4, 11 plus 5, 16, right? 16 over 6 is what? 16 over 6 is what?
2.7.
2.7. You have C's whole number. But let's leave it at 2.7. You have 2 whole number. Remember what? 6 here is 12. 4 over 6, that's 2 over 3. Something like that. Okay, so 2.7, this is our mean. Now, how does each of these how does each of these data points vary from the mean? What is the distance? What is the difference? What is the spread? Anyhow you want to put it, how does it deviate from the mean? Okay, what is the difference between the individual data point? How does it deviate from the mean? All right, so 2.7, if you start doing 2 point, so let's say you want to calculate the mean, the symbol for mean is sigma. This, sorry, I say mean, the symbol for variance is sigma square. Sigma square. Don't mind the way it looks, so sigma square. Something like this. Then 2 on it. We call it sigma. SIGMA. Yeah, sigma. Let me not spell that. Yeah. So let's use a more straightforward data point. 1.1.2 require calculator now. So let's say that we have 2 different data sets. Let me give you example. So let's say we have -10. We have -10, like in a number line. Do you remember a number line? Yeah. Oh my God, junior secondary school. 0, -10, 10, 0, 10. Then we have, I want something, making squares with tens are easier and faster because of our time. 20, 30. Okay. So we have this. Don't mind this pen. It's not straightforward pen. Then we have another data set. 8, 9, 10, 11, 12. Of course, comma, 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 comma. Now, this is minus, so this is not y. This is -10. So if you take the average here, -10 plus 0, -10, we obviously cancel out +10. Then you have 20 plus 30. That is 50 over 1, 2, 3, 4, 5. 50 over 5 is what? 10, Abby? I hope we are following. This is like the
Yes, we are
mean here.
following.
Yes, this is like the mean here. Then here we have 8 plus 9 is 17 plus 10, 27 plus 11, 38 plus 12 is what? Still 50. 50 over 5 is still 10. So we have these 2 different data sets. They have the same mean. The mean, or why is this? Please ignore that 0. Yeah. So they have the same mean of 10, 10. But then how do they vary? What is the degree of variability of the mean? Okay. How do we know how the data points are spread from the mean? Are they close to the mean or far away from the mean? Okay. So the variance is going to help us to find that out. And like I said, this is the formula sigma. What do we do? So what we are going to do is we'll find the difference between each of the data points and the mean, and then we square it. Okay. So we take the data point minus the mean, and then we square it. So you're going to have something like, -10 minus this 10 that is the mean, right? Then you square unmute yourself. Welcome to class, Olubinga. I just admitted him. So let's continue with what we are doing. Yeah. Here is our pen now. Minus 10 minus 10 would get the square, right? Plus, what's the next thing? We have 0 minus 10, right? Minus our mean, 0 minus 10. And then we square it, right? Plus 10 minus 10, right? Are we following? Don't mind what I'm writing in my slide, though. I'll still clean it up. 10 minus 10. Do we remember?
Yes.
And then we square it, right? Plus, we have 20 minus 10. We square plus finally 30 minus 10 space. So this is where I wasted my space. Something like that. Don't mind the way blah, blah, blah. You understand what I'm saying, square. So all over 5, the number of 1, 2, 3, 4, all over the number of our data points, which is 5. So what do we have? What we have here, minus 10 is minus 20, right? Minus 20 square is minus 20 times minus 20 is 400, okay? So we have 400. Plus 0 minus 10 is minus 10. Okay, minus 10 square is 100. Remember when minus times minus? So when we square minus, it becomes plus. Here is 10 minus 10 is 0. Obviously, that is 0. We are leaving that off. Plus, then we have 20 minus 10 is 10. 10 square is another 100. Right? Plus 30 minus 10 is 20. 20 square is another 400. Over 5. Oh. So let me erase this one. So what's our summation? Have you added everything? Tell me our value. 400 plus 100, 500, 600. This is 1,000 over 5. So 1,000 over 5 is what? 1,000 over 5 is 200. So the variance for this particular data set like this now is 500. Sorry, it's 200 rather. The variance is 200. We remember, right? Am I reminding you of your basic statistics? So the variance here, let me even take it off here and the variance here the variance is what? but this particular data set is 200. Okay, now what about this particular data set? What happens here? What's the variance that we have here? After this, with standard deviation, we'll just call it a night. Tomorrow I'll be on next week. We'll continue. We'll go deeper and we'll cover a lot more in statistics before we go into probability. All right, these things are important because of machine learning, data science. Yeah. They are important, right? Sigma, and then error. Before you know it, we start looking at mean error, mean squared error, all of those things. It's important for interpreting machine learning output. So we take it from the basics like this. All right, so here we have it's a separate data set, 8, 9, 10, 11, 12, and then we are looking at the variance this time around. What do we do? So as usual, we pick up the first data. We have 8 minus the mean, right? 8 minus 10. 8 minus 10 square, right? Please don't mind this pen, or at least you understand what I'm saying. It's not like a normal whiteboard. Okay, then 8 minus 10 plus, what's the next value? 9 minus 10, right? Oh my goodness, this 9 is looking wonderful. 9 minus 10 square plus, what do we have again? We have 10 minus 10 square. Obviously, that's 0. Let's not waste our time. Plus 11 minus oh, this 11 is beautiful. Oh. 11 minus 10 square plus, we have 12 minus 10, right? Square. So notice that we have 8 minus 10 is 2. 2 square is what? 4, right? Then we have 9 minus 10. So no, that's minus 2. 8 minus 10 is minus 2. Minus 2 times minus 2 is still 4. 9 minus 10 minus 1. Minus 1 square is still 1, right? Plus 1. This is 0. 11 minus 10 is 1 square, which is still 1. Then 12 minus 10 is 2. 2 square is 4. All over how many? 5. Our number of values. So finally, our sigma square, which is our variance, is what? We have 4 plus 1, 5, 6, 10 over 5, 2. So notice the difference between the two data sets. Even though we arrived at the same mean for the two data sets, they have different variance. Okay, they have different variance. But of course, if you look at this 200, it looks ambiguous. It's just like a number like that. You'll be wondering, how can we have data sets from minus 10 to 30, right? And the difference between them that we can see are like 10, 10, 10, 10. Oh, how come we are not having a variance dispersion that is giving us 200? It can be confusing to some people. Okay. So what would you do in that kind of scenario? So because of this kind of confusion, right, it is not so clear. statisticians decided to include or to introduce the standard deviation. So the standard deviation is a more acceptable, or let's say the most acceptable of these three measures of dispersion. The standard deviation is the most acceptable of the three of them. Why? I'm going to show you why. Because the value that it brings out is usually more realistic in most cases, right? So now we've looked at the variance. What is the standard deviation? The standard deviation is just the square root of this variance. So we have variance. Our variance is sigma square. Sigma square. What is the square root of that variance? And of course, in mathematics, you know that when you have a square and a square root, your square root will cancel out your square, right? Do you remember? And you have just sigma. Who remembers basic statistics? So is there anybody here that did not do basic statistics? Let me know. Anybody? Anybody? Mathematics, even in math, we're taught square roots, squares and square roots. Okay, so let me take it again. The square root of this variance is our standard deviation. So we have square root. Oh, the square root of our variance being our standard deviation, and our value of formula, or no, it's not formula. It's not the formula. I've not introduced formula yet. I'll introduce formulas next week. So let me not confuse you guys. So this is just the sigma, which is our standard deviation. Now, how do we calculate the standard deviation? Simple. We take the square root of 200. So the standard deviation for this one, we take the square root of 200. What's the square root of 200? Square root of 200. Remember here, the sigma square here was 2, right? For this one, the sigma square here was 2, right? So our standard deviation is going to be the square root of, let me put it this way, the square root of 2. So what's the square root of 200? You have something like
14.14.
10.14 or 10 into square root of 2. $100. Do you get? Oh, 10.14. So why I put it this way? Of course, this is the way we write it in math, but of system we give you the right one. So this is 10.14. Please forgive this pen. Let's just forgive this pen. Right? So we have 10.14. Okay, which means this one is going to be 0.14, right? Are we correct? Please confirm. So because if you notice, what we have here is like 10 times what we have here. Even though they had the same mean, Remember, they had the same mean. They had the same mean arithmetically. The measures of the variability or spread in the two data sets were too wide. So this one is more realistic. Notice that this one is closer to the real value. Is this 10.14 or 1.014? If you are with calculator, check it.
The first
Is it
one
1 point?
was 14.14, while the second one is 1.14, I guess.
Okay, this one is 14.14.
Yes.
Okay, so let's change this to 14.14. This one is 1.14, right?
1.4. No, 1.4.
1.4. Yeah, so I think it's correct because obviously if you look at it, you see that whatever you get here is 10 times of what you have here. 10 times of what you have here. All right. So these are some of the measures of central tendency. From next week, we'll go into the graphicals. We look at histograms, the bell curve. We look at some box and whiskers. Then we'll go into how we apply this into data analytics. We'll do some applications into data analytics. But when we start data science or machine learning, you see you won't be calculating it yourself. The system runs it. When you run your model, yes, when you run your model in most machine learning platforms, whether you're writing with code or low code, no code softwares, they'll bring up those values for you. But do you understand them? Do you understand? So it will tell you the standard deviation. Maybe you ran statistics and it brought out variance, standard deviation, F statistics, ERR, blah, 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 MRR, la, 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 la. How do you interpret your result? How do you understand that output that was generated? Do you understand? That is why you need to have foundational understandings like this. And these are the things we'll be doing in DataCampus. So you know that, standard deviation is 1 point something. That means there are no much variability in the data set. Okay, if the data standard deviation is about 80 something, blah, 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 or something, 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 the higher the standard deviation, the more variability you have in your data. Do you understand? You already know that. And some other statistics that we're going to be bringing in, okay, that are very relevant so that you'll be able to interpret results and know the kind of what to do in what instance. We'll apply them in foundational data reasoning and then bring them real life into our data science work and project. I think we've had a nice time this evening. Our time is fast spent. It's almost an hour of recording, which I promised us every Sunday. See you next Sunday. So do you have any question? Let me stop presenting. Do you have any question?
Yes,
Any
I
questions?
have a question. Can you
Yeah,
hear me?
a different care. Yes,
All
please.
right,
Yes,
thank
please.
you. Okay, thank you very much,
Yeah.
Stella. So I want to
Yeah.
ask, okay, so is there any relationship between standard deviation and outlier in a data set?
Standard deviation and outlier. There is really no the standard deviation may not really help you find the outlier. Okay, because the outlier may just be one or more data points that are far from the mean. But remember that when you're doing the variance, standard deviation, as we are talking about variance now, I think it's variance that is closer that could help you even identify outlier more than standard deviation, because you come to standard deviation, you've already compared each of the data points from, I've stopped sharing. I would have shown you try to draft a graph or something. Let me see if I can do that. So let me show you something. It's a bit advanced. It's more like what we could look into next week or 2 weeks time even. Let me share my screen so I can just draft a graph for you. Okay, I'm still sharing even. Am I still sharing?
You just stopped sharing now.
Oh, really? I didn't even know. I stopped presenting from my end, so I thought the sharing had ended. So let me share it again. Let me share. So there is something that is going to help more with outliers. It is called the line of best fit. Oh, I don't have my pen here. Oh, where is that pen? Okay, don't worry, for your sake. Let me present again so that I can get that pen to show you. So when we are looking at mean errors, right? Let me show you something. This is not what I want to show you. So when we move on, you're going to really understand because we are going to have something like this, right? Let's say we have different data points. Let's say all these things, all these points represent different data points, different data points, different data points. Don't mind the size of the whatever I'm drawing, no. But just say that you have a graph. These are different data points. Let's say these are different heights of or length of our different customers that we are to solve for, stuffs like this. Okay, this is another way to explain the variance and all of that. So we have something we call a line of best fit somewhere in the middle here. So you draw a straight line and then you begin to measure the distance between each data point from the average. Distance between this and this. Distance between this data point and this. Distance between this data point and this. This is, do you understand? This is how we get that minus data point 10 minus average or mean. Do you understand? If you have an outlier is going to be very far away from the mean. If you plot it in a graph, you're going to see it. You're going to have a data that is very far away. These ones, you will see data points that revolve around the mean. So we'll be looking at mean squared error, mean standard error, all of those things. Do you understand? So when you plot it, you're going to see the one that has the highest distance from the mean. That is your outlier. Do you understand?
Perfectly. Thank you.
Okay, you understand? Yeah, very,
Yeah.
very far away from the mean. Maybe even down, far away. Something that is very, so you will see the ones that are close, that cluster around the mean. You see the ones that are very far away. So variance and mean errors and all of those things, mean standard errors, those are some of the things that can help you identify the outliers in a data set. All right, so that was just, but we will get there. Okay, just don't miss out from DataCampus. We'll
All
get
right.
there, right?
Thank you. Yeah, thank you.
Yeah. All right. So let's take it easy, one step at a time. Okay, so do we have any other question before
Yes, ma'am. Yes,
we call
ma'am.
it in? Yes. Whose
I've
question
been.
is it?
It's
Where,
God.
excuse me,
Yeah, who's speaking?
where are we
Should I stop
putting the
presenting? Am
recorded
I going
video?
to illustrate anything? No, in the general Kedros Academy, it's for everybody. So invite your
Oh,
friends.
okay. Okay, fine.
Yes, yes. And we
Uh,
could, who knows, we could even share it in our YouTube channel also. Yeah. So we could upload it in our YouTube channel. What do you think? So you can always go there and watch it, right?
Yeah, okay.
Yeah, and then share the link. That's another one we can do so that we just have it as a series there. You can always go and check it out and watch it. Okay, so this is our
Yeah.
very first class on statistics. We are going to build from here. Thank you all for joining. Let me end.
ma'am, just one question.
Okay, please.
I've been hearing of the terms outliers. So I want to know what are they. Yeah, outliers. What are they? What do they stand for? And what do they mean?
Oh, I just explained it, but we'll still explain it more. Okay, let me explain it. So you have a data set, and then you have a data that is a data point that is significantly different from the rest. Okay, what it does to your data set is that it could give your data, your output, it could make you generate a wrong output. For instance, you have customers, you have a customer's data set that contains age of your customers. Then you have ages ranging from 20 to 35. Okay, between 20 to 35, your customers are within 20 to 35 age range. Then you have this customer that is 96 years old. Yeah. Now, if you're taking the average of your customers, you're going to get a spurious output. Let me use the word spurious. Yeah, sorry for using that word. That's a statistical word. That's the word my lecturers used to use then. So you're going to have a spurious result. Why? So instead of you to have a mean or average of your customer's age that is maybe 30 or 31 or 32 as average, do you understand? Or let's say around 28, 29, 30, you now have average of 57 or 56 or 49. Do you understand? Now, that average is not a good representation of your data. Is that correct? It does not, because of that single figure that is way above others, that is an outlier. So it is affecting your descriptive statistics, it's affecting your output, it's affecting both your dispersion, your measures of central tendency. Godwin, do you understand? Do you understand what I
Yes,
just
ma'am. Yes,
explained?
ma'am.
Yes. So it's
Yes,
going
I
to
do.
give you a spurious output. So how do you handle outliers? We are going to come to that. We'll bring in what we call normalization. Okay, so normalization would help to balance out those outliers such that handle them, the system will have a way to handle them, either it removes them or just normalize the data so that the outliers are not there. And that would help you have a more realistic data. So imagine that because of that single customer that is 96 years old, he has pulled your mean from 32 to 48 or 50, or let's say 47, and you are to target customers for your let's say Christmas sales, you're running ad, and instead of you to now put between 30 something that is supposed to be your average or your mean, right? You're not targeting people of 47, 50 something years old. You will not get a good output. You're going to have a wrong experience. Okay. You may be wondering, why is this ad not converting? Why are customers not coming? Why are they not buying my market? You targeted the wrong people because you got the wrong result from the data. And that data is the wrong result is because of the outlier that you have in your data set. Or maybe you even have somebody that is just 2 years old. You see, it has pulled it down. So instead of having average of that 30, 28 to 30, you may have average of 15 or 14 or 12. And then you now end up targeting teenagers when you're supposed to be targeting the adults. Do you understand? Yeah, so outliers are not so good for your data. They can be malicious. So you need to be able to identify them. That is part of why you do exploratory data analysis. Identify them, and you're able to handle them in such a way that it does not make you come up with a wrong data analysis output or data science output, whichever one you're doing. Do you understand? Is it clear? I think
Yes,
it's
ma'am.
clear,
Yes,
right?
ma'am. Yeah.
Awesome. Yeah. Any other question? So we call it a night. I'm going to share the link to the recording in our class. I'll share it also. I'll upload it to YouTube and then share it so that other people can watch it. It will just be there'll be playlist for Data Campus, okay? So you can always catch up with the classes. All right, everyone. It was nice having you. Thank you for joining again. Adeleye. Oh, I
Yes, ma.
celebrate you. Stephen. Thank you. Adefunke, Paddy, I celebrate you.
Thank you
God
too.
doing. Olugbenga. Is Olugbenga? I don't know. Hi, Olugbenga. May I know you, please?
Yeah, I'm
Someone
raising my hand
invited
here.
you, right?
I think I got an invite from your. Can you hear me?
Yeah.
I think I got an invite for maybe visiting your website or thereabouts. And
Oh, I think
I
maybe
just
you have indicated you filled our form at some time in the past. And so
yes,
we have
yes,
your
I did.
mail.
I did.
Okay, okay.
But my question is that this
Mm.
class, this course, is it just beginning or it's been on for a while?
Okay, this is Data Campus. This is not Data Analysis Bootcamp. To join our Data Analysis Bootcamp, we have one that is starting this coming Friday.
Okay, so what's Data Campus handling? What's it about? All
Data
about?
Campus is free. Every Sunday, you learn about data analysis, data science, basically
Yeah,
data
okay.
science, machine learning, AI.
Okay. So every Sunday is a free class like that at the same time, right? Is it 7 o'clock
7
or
to
6
8
o'clock?
is 7, is 7, is 7. We didn't
7
start
to
on time
8
today
p.m.
because people didn't join. Yes, 7 to 8, just an
Okay.
hour. All right.
Yeah, I didn't know. I just checked I didn't check my mails. I think the mail I would have dropped earlier. It just took me some time to look at the mail. I got it late. I even thought the class would have ended. I just let me just try and see if they could still
Oh,
be there. And lo and behold, you guys are still there.
and
Thank you for
thank you
being
for
there.
joining.
Thank you for
Yeah, we
the
celebrate
class.
you.
I hope
Yeah.
I could be able
Please invite your
to.
friends, okay?
Okay, no wahala.
Every
I'll let
Sunday
them know
free
like this.
evening class. Yes, yeah.
Okay,
All
fine,
right.
fine. No problem.
Yeah,
Well done,
at
Stanley.
t.me/Kedros Academy is our data community on Telegram, and it's our Data Campus. All right. So
Okay.
if you have questions
Okay.
also during the week, please feel free to ask on the platform. I think all of us here and other people would be able to respond to you.
Okay, on the Telegram platform, Abi?
Yes, it's for interaction.
I think I'll locate that and join right away.
All right. Okay,
All right.
so thank you
Thank
all
you.
for joining. Do have a fantastic evening. Bye.
Bye bye.
Bye bye.
Bye. Thank you very much.